Okay, algebra students, I am going to be going through lesson 54 with you right now, and how to do these problems, or the problems that are going to be introduced here, take up a lot of space. As you can see, I'm going to be, I've given us in our notes a lot of space on the front and back. So these are our notes. I'm going to go through them, and when I get to an example, it would be, and it's something you think you can attempt on your own, I would go ahead and attempt it, and then, put me on pause, and then attempt it, and then turn the video back on or unpause it, push play again, and see how close you were to actually doing it correctly. That's the best way to learn, is kind of experiment on your own and then see if it made sense to if it worked. Okay, so I'm looking at our notes here. I wrote these a few years ago, so I will be learning right along with you on what I wrote and what I meant to teach. So they use something very scary sounding called a substitution axiom in this lesson. And we're talking about solving more than one equation, okay? What that means is when you are solving more than one equation, we're going to look at this picture here because this kind of tells you what it is that I'm talking about. Here is a graph of line 1 and line 2, okay? They each, as we've learned, every graph has an equation attached to it, okay? And where those equations, when we solve those two equations, we are actually finding the point where the two lines cross, okay? So when it says solve two equations or solve the system of equations, it means where do those two lines cross, okay? And the answer, if it's a point, is going to be an ordered pair. It's going to have a coordinate, okay? So that's just the basic start on what we're doing, okay? And in this lesson, we're going to learn by substitution. Okay, so here we have two equations. These both represent two different lines, okay? They're in different forms. One is 2x minus y equals 1, so the x's and the y's are on the left side, and there's a number over here. In this case, x is by itself here, and all the numbers are over there. I'm going to finish this one in a poor, not such a good video quality, and then I'm going to try and up the video quality on the next video, but I don't want to go back and start over. Okay, so substitution, this is the tricky part. This is my empty equation. This actually has, what we did was take this equation, 2x minus y equals 1, and plug in wherever there was an x up here, put this in, okay? So x equals this. So if that's true, we're going to take this and put it in there, okay? So, and this is the equation 2x minus y equals 1. So this is actually this equation. And then we're going to put this equation, or this value for x, in where x was. So I'm going to substitute the x here with this. Okay, so that means we put minus 3y plus 11 in there. Okay, and now this is something that you guys have all done before. It's been a while because we just had Christmas break, so you might be pretty rusty. Okay, so we have a 2 on the outside, and we want to get rid of parentheses first when we are solving equations, and we know we're on the right track when all we have is we only have one letter in the equation. Okay, if we had x's and y's, we can't solve it. We need to have only, we can't have two different letters in there or variables. We just have one variable. Okay, so 2 times negative 3 is negative 6y. 2 times 11 is plus 22. Minus y equals 1. Okay, so then what we do in all equations is we combine like terms. Okay, so I see negative 6y and a negative y, so those do it together and make a negative 7y plus 22 equals 1. Okay, so we want to get y by itself right there. So let's go ahead and subtract 22 from both sides. Okay, and try and give you enough time without going too fast. I'll get the hang of this. And negative 22 and a positive 1 is a negative 21. Okay, so we're almost there. We almost know what y is. We can divide both sides by negative 7, and it's always nice when you see something like this because it means it works when it divides perfectly. So we get y equals a positive 3 because it was a negative divided by a negative. Okay, now the bummer with these problems is once you get to this point, it is why we're not done, because like I said over here, we need an x and a y value for our final answer. So that means if I'm going to write the final answer here, our final answer is going to look like this. Now we just found out the y value, so that goes over here, but we still need our x. How are we going to find that out? Well, we take our y and we go way back up here and plug in 3 into this equation or this equation, whichever one, and find out what x is. Now, because x is by itself here, if I plug in 3 for y, we get a negative 9 plus 11. So see how I'm using this equation? Negative 3 times 3, because that's what we got with our y. Okay, plus 11 equals negative 9 plus 11 equals 2. Okay, so we just found out x equals 2. So that actually goes here. And that's your final answer for example 1. Okay, now in case you ever get lost or what I did, you need to see it done one other way. You can always go look in the book. And this was example 1, I believe. And not only, I was going to see if they want us to, they like us to check, okay? And I'm not going to do that right now, but if we were going to check, we would take these two and plug them into both of those equations, but I've run out of room. So we're going to leave it at that, and especially since this is for example. So I'm going to see if they want us to test the next one. Maybe they don't. They wrote so much in this lesson that it's a little overwhelming. So hopefully my notes will help you. Okay. Example 2. It says use substitution to solve for x and y, just like we did up above. Okay. Now, and I already got us started. But when I look at these equations, okay, they always, it's nice when they give us a hint. When they're doing substitution, books always, or tend to, at the beginning, isolate one variable. So y equals x minus 6. So y is already by itself here. So that means we could replace this y right here with x minus 6. And I started it over here. So, okay, I wrote 2x plus 3y, here's where y is, equals negative 13. So we plug in this over into the hole there, okay? So we write x minus 6. This is probably the trickiest part about these, is knowing what to put where, okay? So now it's something you've done many times before. We get rid of the parentheses, so we don't do anything with 2x plus, and now we multiply the 3 through. 3x minus 18 equals negative 13, okay? And then remember that list of instructions on how you solve these. Now we combine like terms, so 2x and 3x makes 5x minus 18 equals negative 13. Okay, and now we go ahead and add 18 to both sides because we're trying to get the x by itself. Okay. Okay, so now we've got 5x equals 5. Isn't that nice and neat and tidy? Okay, so we divide both sides by 5. And we get x equals 1. All right, but again, we're not done. If we were going to be writing it as an answer, all we have is half of our answer. Okay, because we want an ordered pair. We're trying to find where these two lines, these equations that represent two lines, we want to know where they cross, at what point. Okay, so they cross at 1, and now we've got to take this x equals 1 and plug it in up to one of our original equations. I always like the one where y is already isolated. So if we have y equals, we're going to plug in 1 for x, which we had found. And so it looks like y equals -5. Okay, so then that is the rest of our answer there, 1, -5. Okay, now if you turn your page to the next set, it looks like we have only one more practice problem. I must have skipped a little bit, or one more example. I must have, I think I skipped 1 or 2, which I'm not too happy about. I might go ahead and add them in. Okay, because this says example 4. This was example 2. So did I skip 3? I did. So I'm going to get a blank, or I'm going to do example 3 on the whiteboard. Okay. So example 3. See how if this is going to be focused good enough. Okay. Example 3 is to use substitution to solve 3x, and this is in your book, plus 2y. It's at the top of page 221 equals 3. Okay, and then they also gave us x equals 3y. Isn't it nice? They already isolate 1, which tells me I'm going to put this one into this equation. Okay, so now we take the shell of x there and plug in the other equation. Plus 2y equals 3. Okay. And once we get to that, again, it's stuff that you've done before, because you guys are awesome. So I get 9y minus 30 plus 2y equals 3. Now that reminds me, I notice a lot of people forget to multiply the 3 through everybody. They always remember the 9y and then often forget to do the 3 times the -10. So always be careful of that second term. Okay, so now I'm going to combine like terms. We get 11y minus 30 equals 3. Okay, so 11y equals, oh, forgot to add that for you. You'll get better at just doing them without having to show it all, but for now I want to show it. Okay, so divide both sides by 11, and y equals 3. Now you might be wondering, where are you supposed to write all this? I actually want you to do this on a piece of paper and attach it to your lesson for me, okay? Because I do want you to do every example, because this is a new concept. Okay, so are we done? We have y equals 3. No, but we're half done. We have part of our ordered pair. The y is the second one. So now we take 3 and go all the way back up to our original equations, and I can plug in 3 here or 3 here. I kind of like it when it's this one where it just has, so it would be like maybe x equals 3, and then y is 3 minus 10. So I took this up here, okay? See that? And put it down here. And so that equals 9 minus 10, which equals -1. Okay? So that means we found the second half of our answer. So our answer is that. Now, yes, do you guys see all that writing for this? That's why some people don't enjoy these types of problems very much, but I actually do like them, and especially when it works out. If you make a mistake, it can cost you a lot of time. Whoops. But I just want you to be patient, okay? So that you don't make a mistake and have to repeat and do it again. Okay, so here is the last one of this lesson. Use substitution to solve for x and y, and they give us these two things. Now both x and y are isolated, so it gives us some options. We could put, well no, sorry, I was looking at it from far away. So this one is isolated already, so I like to put, then if y equals this, then I put negative 3x plus 8 in for y up here. Okay, so what I mean is I'm going to take negative x, our first equation. You see that? There's my space to put all that in, equals 4. Okay, so then we put in negative 3x plus 8. Okay, so once you get the hang of what to put in where and how to substitute, the rest should be pretty much review. Okay, so negative x, I'm going to get rid of the parentheses, multiply through, so negative 2 times a negative 3 is a positive 6x, okay? A negative 2 times a positive 8 is negative 16 equals 4. Okay, now we combine like terms. A negative x and a positive 6 is going to be a positive 5x minus 16 equals 4. Okay, add 16 to both sides. And it looks like we have 5x, I'm running out of room here, equals 20. Okay, so if we divide both sides by 5, I'm going to have to move over here. We get x equals 4. Okay, again, it's a lot of work, all that, and we are half done. Okay, well, more than half done, because we've done most of the job. Okay, so over there I'm writing my answer. Okay, so now I have x equals 4, and I'm going to go back into our original equation and use this one to find out what y is. Y equals negative 3 times the 4 that we got for x plus 8 equals negative 7 plus 8 equals 1. Okay, so it looks like we got 4, 1. And I just got hung up for a minute because did I get the wrong answer there? Yeah, I think I just totally made a mistake. So apologize, back up here. I only made the mistake here. I added. A lot going on trying to do the video on this. I will get better at it, I'm sure. Okay, so negative 3 times 4 is not 7. That would be not even close. So I must have added, I don't even know. So negative 12 plus 8. And negative 12 plus 8 is negative 4. Okay, that is what I was really looking for there. Apologize for that, but just like normal day at Avery and Carly's house, I make mistakes. So I could go back and re-record this whole thing, but it's been 20 minutes, and so I'm just going to keep it with that mistake in there. All right, so it looks like we have 2 practice problems. Okay, so that's nice. They also gave me there's one other example, example 5, that I left out. So I'm actually going to do that on the whiteboard again, even if this lesson tends to be longer. It's different, and so I want to make sure that we learn the whole thing. Okay, so we're almost done. You still only have 2 practice problems for this lesson, but this one says to use, this one is different, substitution for this problem, these 2 equations, okay? But then they also say x equals y, all right? So that's a weird substitution, isn't it? Well, there's not much you can do here. If x equals y, we could put y up here for x or x up here for y. What I mean is you can either do 2x plus 3x equals 5 and solve it that way, Or we can use the y and put the y in instead. So 2y plus 3y equals 5. All right, so I either replaced x with y or y with x in both of them. So I'm actually going to solve each of them both ways. Okay, so what that gives us is 5x equals 5. Divide both sides by 5. And we get x equals 1. Now if we do it the same over here, we get 5y equals 5. Divide both sides by 5. And we get y equals 1. Okay, so I actually got the answer to both of them. We got x is 1 and y is 1. So that's our final answer. But if we'd gotten x equals 1 and x is the same as y, which then 1 and 1. Okay, so that one's a little different, but it's the same skill that we use. Okay, so that wraps it up. You have 2 practice problems for this, and I will get ready to teach you lesson 55. All right.